somebody speaking, right? Thank you very much, everybody, for coming to the snack BOF. And so this is working group forming BOF, and we'll kind of share our goals before going forward. And there's quite a bit of remote participants. So when you talk, please state your name, or like, go use the app to sign on to the queue. And next slide. Go to the Notewell, yeah. So this meeting is bound by the Notewell. So we're not expected to read all the text that's in here, but generally whatever you say here is like a contribution. So please be mindful of that. And there's like a bunch of RFCs you can read as to what that means. Thank you. And this is like a Meet Echo steps. You've probably already seen this, either as a remote participant or a on-site participant. So please follow the thing, because we need to manage a queue between both physical and remote participants. Thank you. Next slide. So what we're trying to do is, since it's like a BOF, we are trying to focus a lot on the problem statement itself and see if we need to work on this. And we're going to spend the bulk of the time of the meeting discussing the problems and not really the solutions. So we start off with like 5 minutes, like for all this like housekeeping work that the chairs need to do. And then we kind of hand it off to Ted to kind of start talking about what are the problems to solve. And then also Jonathan and Michael also have other things to talk about in the problem space. And after that, and try to keep your questions to a minimum, like use just clarifying questions in this first part, but we'll have time at the end of the presentations for any kind of questions. So if you have questions about anything that people talked about, please feel free to invoke them and say like, hey, I had a question on whatever, which is not a clarifying question, why this is necessary and so on. So you can ask those questions later. And then we have a few questions before we start discussing what's on the charter. And we're going to go through the charter. It's like dense text. So we'll probably just go through a PDF like that came out of Google Docs. And we go line by line or paragraph by paragraph and see what people think about it. And at the end, we want to poll the room and people who are participating as to what they think about this charter and this problem statement and whether we should work on it. Of course, everything to be confirmed on a mailing list afterwards. But the idea is to figure out at the end of the day whether this work is going to go forward and in what form. So that's kind of what we are shooting for. Thank you. So this is like verbatim from like RFC 5434. So what are we trying to do here, right? So we want to figure out if this, I don't know if it's like too difficult to read, but it's pretty much summarizing what I was saying before, like whether there's a problem worth solving and is IETF the right place to solve it. That's like a high level goal of what we are trying to do here. So, and that's what we're shooting towards. So if you see us cutting you off or like cutting the mic line at some point, this is really the goal, because we want to get to a solution at the end of the day today. Thank you. And that's it. I think we can swap over to Ted's presentation. So if you have any questions about the agenda, now would be a good time to ask. Danielle, you were asking for presentation permissions. Okay, thank you. Thanks. Okay, so Ted, please, thanks.
I don't see a remote, so I'll steer the slides for you,
Oh.
or you can go ahead yourself.
Okay, yeah, I might want to do that because we've got all these charts now. Okay. So we want to flip back and forth. All right, so I'm going to just, let's see. Can you guys hear me back there? Okay, great. We got some instruction from Karsten about how to use the mic. So I'm going to talk a bit about the Stub networks problem that that we saw and that we'd like to discuss in the IETF. Oh. mic is on. It may just not be picking up my voice very well. Let's see. So, yeah. All right. Masks. All right. So, wow, this is, I can't really see my slides. Yeah. Well, if let's just point this at me. I can read that. Okay. So, yeah, so the problem statement, basically, we already have this ability that we've developed in the IETF over the last however many years, that if you have like some kind of host and you want to connect it to your network, you can just connect it to the network. Oh no.
Do you want to hold the mic?
Oh no, it's the slides.
Okay.
The slides are not showing up in the Meet Echo. That may be why we're seeing the scan me on this screen. Okay, so this is a good barometer. Okay, yay! Okay, so I'm going to try and stand right in front of the mic, and hopefully we'll be able to see the slides. It hates us. So I think you may need to acknowledge, somebody may need to acknowledge it.
I'm not on the.
I am.
I think the expert is coming.
I think
chair.
I have an idea.
There shouldn't be a pop-up saying.
Oh, right.
Otherwise, Suresh, you could just share from your laptop. It's probably easiest.
Well, we actually want to share it from this laptop so that I can control it. We don't seem to have a flight here. Ooh, fancy.
Hang on, I'll just bring my laptop and we can share from my laptop, and then you can push. You got it?
It should come. It's
Okay, good. There we go.
Okay, that looks good. All right. So the problem we're trying to talk about here is we already know how to connect hosts to networks pretty much automatically. Like, you know, you might have to punch in some authentication information or something like that, but it's an understood problem. We know how to do it. You can connect your phone or your laptop or whatever to any network that you need to, and the infrastructure to do that is there. But the problem we have is that we don't have that same ability in the case of a stub network. And so this became an issue it was an issue that was high on our radar at Apple, because we wanted to be able to connect IoT networks to infrastructure. And infrastructure meaning like your home Wi-Fi. And we need to do that automatically. We didn't want to have we didn't want the end user to have to be an expert to make it work. So, and just to talk about like the problem that we're trying to solve here, we want hosts that are on these stub networks. Stub network, just to talk about that a little bit, is a network that's attached to another network, dependent on that network, and doesn't provide routing. So we wanted to be able to attach that kind of network to an infrastructure network. We wanted mutual reachability between hosts on the infrastructure and hosts on the stub network, and mutual discoverability. So like if you've got a light bulb on the stub network, you want to be able to control that light bulb from a device that's on the infrastructure network. Is there anything else to say about this? Yeah, so that's the basic idea. Connect a stub network, get the same experience that a host on the infrastructure should have the exact same experience as a host on the stub network in terms of using the local network resources. And you know, we've seen solutions to this that sort of happen accidentally. Just to show you the topology here, basically home network, you plug another CU router into your home network. suddenly you have two networks, but it doesn't work that well. This doesn't really solve our problem. In theory, devices on the inner link can reach the outer devices on the outer link, but there's no reachability in the other direction, and there's no service discovery between links. And devices on both links can reach the internet, and so you actually see these networks fairly frequently in people's homes accidentally. They didn't intend to set up a network like this, but they've set one up, and then they have all these problems. They have service discovery problems and just all kinds of problems. So, and this basically only works if you're trying to reach out to the cloud. So, just to talk about goals, the primary goal that I had for this work, and that I hope is of interest to the IETF, is enabling mutual reachability between stub hosts and infrastructure network hosts, enabling mutual discoverability. So the ability to, like, suppose you want to find a printer on the stub network, you can, even if you're on the infrastructure network, and vice versa. And also the ability to do things like firmware downloads for hosts that are on the stub network. It would also be nice to be able to actually integrate the stub network into the routing infrastructure of a network that's capable of doing that. And it would be nice to be able to integrate the discovery infrastructure on the stub network into the infrastructure on the main network, so that devices that are on the stub network can be discovered not only from the adjacent infrastructure link, but from any link on the network.
Take mic out of stand. Hold in front of face, please. Stop turning away.
Sorry.
Chris Morrow, Google. Thank you.
Okay. All right. So some constraints. We can't change the existing network. This is a huge problem, right? Like we actually looked at this problem in HomeNet and came up with a solution, but the solution required a complete change to how the devices on the home network worked, and that just didn't fly. That was a failure. We never managed to get any home routers that anybody's shipping to implement that. So basically, this has to work without anything changing, without the user having to buy a special router for their home network that supports it. And also, like, we can't really require changes to hosts on the infrastructure, because once again, the customer's already bought those hosts. It just has to work. For devices that are connected to the stub network, there's kind of two scenarios. One is you've got a greenfield network where you don't already have an existing way that devices on that network behave, and so it's okay to say how they behave. And the example would be an IoT network where right now the IoT network doesn't support IP routing, and so how it's going to support IP routing is something that we can define. Another example would be like the double NAT, except you don't want to, you want to actually have mutual discoverability and all that nice stuff. And in that case, hosts just have to work. So, and then just some topology constraints to keep the problem small. We don't want to do routing. So stub networks are not transit networks. It's possible, there were some questions that came up on the mailing list, so I just kind of represented these here. It's totally possible for there to be more than one stub router connected to the stub network. That has to work. It's possible because the users are just going to connect these to the networks, right? Like we're explicitly assuming that the user doesn't know how to operate a network. They just buy devices and plug them together, and the devices have to kind of figure out how to make it work. So it's entirely possible that the user could plug two stub routers that are connected to the same stub network into different infrastructure networks. And we at least have to acknowledge that that situation can occur and handle it somehow. So, the obvious simple topology is just you have a CU router, you have a home LAN, you have a stub network, you have a single stub router. Very simple. But we also need to support this use case where you just happen to have 2 or n stub routers that are all connected to the same stub network. And that's the topology that could cause some problems, where you have, you have a home network. Maybe you've got a Wi-Fi network in your home, and you've got a routed Wi-Fi network in your garage that's on a different IP subnet, and you've got stub routers connected to both of them. That's got to work, or at least not fail. Some assumptions about how we might solve this problem. We don't really want to get into solutions, but we'll talk a little bit about the solution that we've already done, which may or may not be what the working group decides to work on. But that solution uses IPv6, it uses routing, and it uses DNS Service Discovery to provide addressability, routability, and discoverability mutually between the stub network and the infrastructure network. And currently, if you connect your device to a home network and try to discover a printer, you're probably going to use MDNS, which is DNSSD using multicast DNS. It's widely supported. Pretty much every device that you can buy supports DNSSD. So that's the service discovery technology that we've been talking about and using. And then okay, yeah, so this is the last slide. So, so assuming that this is work that the IETF wants to work on, I think that there are some documents that we need to write. One of them would just be the basic solution that, delivers the minimum viable product. I don't think there's any point in having two documents for the minimum viable product, because doesn't seem like it's that complicated. We could have like a discovery document and a routing document, but I don't know that that's necessary. And it's probably useful to have them together. But then we can also, if that's a success, if we decide to work on that and we succeed in producing it, there are some other things we could do. We could talk about the sort of stretch goals, integrating with the actual routing infrastructure, using real GUAs on the stub network instead of ULAs if we go that way, and integrating DNSSD stuff. So that's basically the problem statement.
Thank you, Ted. Does anybody have clarifying questions on anything Ted said? Okay, Sri, then Carlos.
Quick question, this is not a new problem, right, Ted? Do you agree? So if so, what is driving this requirement now?
So, I mean, in a sense, we're here a little bit late. And the reason we're here and not just saying, screw it, we'll publish a document somewhere else, is because this is really the meat and bones of IETF stuff. Like IETF does service discovery, IETF does IP addressing and routing. And so it doesn't make sense, in my mind, to publish a document that's specific to a particular type of networking a particular type of stub network. I'd like us to document how to make any sort of stub network work. So we've already needed this to connect an IoT network to an infrastructure network. And so we've already done a bunch of work on this, and Jonathan's going to be presenting on that. So that's kind of where this is coming from. That's what motivated us originally. We were really interested in getting this sort of 802.15.4 mesh technology connected to home networks, and we just didn't have a way to do it. But we had all the building blocks.
Right.
And so we just put the building blocks together and kind of made it work. But it would be nice to have a standard that says how that happens.
Okay, thanks. Maybe another follow-up, just quick follow-up, right? So you consider this as a routing problem, or you want to solve this more in the service discovery layer? Where do you want to solve this? Where will the solution set fit?
Well, so the solution that we've implemented is to use router advertisements both to provide reachability, because remember this is a constrained problem. We're not solving the whole problem of like that HomeNet tried to solve. We're just trying to solve the stub network problem. And for a stub network, what we need is to be able to get IPv6 addressing on the stub network and IPv6 addressing, if it's not already present, on the infrastructure link. And we need to be able to tell hosts on the infrastructure link what the route is to the stub network and vice versa. So, so that's pretty simple. You just use router advertisements for that. And then for DNSSD, we've been doing a bunch of work in the DNSSD working group. So there's this concept of an advertising proxy, and there's this concept of service registration. And so devices in the constrained network that we're talking about use the service registration protocol, which is a unicast DNS update protocol to update an authoritative database. And then that authoritative database is advertised on the infrastructure link using multicast DNS. So you'll hear more about that in Jonathan's presentation.
Okay, thank you.
Thank you, Sri. Carlos, go next, but before anybody joins the line, can you also join the line in the Meet Echo? I know Michael, right? Carlos is not, and the line is in a different order than this. So like, yeah, I think we'll go with the room line and we'll go after that. Please join the Meet Echo queue as well. Thank you.
Carlos, whenever you're stream, just, I mean, I was
You should
trying to
probably
join.
pull out the microphone like I'm doing because
yeah,
you're too far away.
Carlos, whenever you're stream, I was trying to join the queue, but
Oh, no worries, Carlos. No,
was not successful. Quick question. In the topology that you presented, did you consider the possibility of like those multi-link topologies, like changes on the topology dynamically, so the stub network connects through one link and then through the other link? This is in scope of the program?
Yeah, this all has to work when things change. So, you know, think about the stub network router as being essentially like from the user's point of view, it's just a home device. Like they don't know that it's a stub network router specifically. I mean, they kind of do, but oh, sorry, I'm waving my hand, and so the mic is pointing away and back. Yeah, so users don't really know. They don't have a mental model, or we don't want to require them to have a mental model. So yeah, they have to be able to take that device and plug it into a different network, or we have to prevent them from doing it. Right, one of the two.
My next.
go ahead, Michael. Like we'll eat the line as it is right now.
Okay. This slide surprised me, Ted. So you said to us it has to either work or not break. And so since I have some knowledge of your proposed solution, I'm not sure how this network either works or doesn't break.
Right.
And actually, could you distinguish those two things, those two statements of work versus not break?
Right. That's a really good question. And so the issue here, this is a problem that we've run into, that, you know, you have devices that are connected to multiple networks and to the stub network. And if you just implement the stub network as, you know, router advertisements pointing in two directions, that kind of works, but you have some issues with the addressability on the home networks. But the big problem is, for a constrained network, you need service discovery, mutual service discovery. And doing mutual service discovery on two different networks where there isn't necessarily, so in this model here, I've been kind of generous and sort of implied that there's an internal router that's doing the right thing. But actually in practice, if this is happening in someone's home, most likely it's a double NAT. And so, so devices that are connected to the garage LAN probably can't communicate with devices that are connected to the home LAN. And so we've got this because it's a double NAT. Well, they also can't connect to them. Well, at least in one direction. So yeah, it's possible that we could make this work.
Can you repeat Michael's comments onto the mic?
Sorry?
Can you repeat Michael's comments onto the mic?
Yeah, so Michael is saying that he's asking whether it's really true that the devices can't communicate back and forth. So in this scenario with the garage LAN and the home LAN, if you assume that the internal router is a double NAT, a second NAT, I should say, then there should be connectivity in one direction or the other. And so one way to solve the problem of communicating between devices like this, so this stub router, if this is a constrained network, we don't want to be doing any kind of heavy data transfer across the stub network, for example, to replicate the authoritative zone that we're maintaining with SRP. And so in order to prevent that from happening, either we want to go around, so we want to use the internal router as a way to communicate between this stub router and this stub router, so as to maintain that database, or we want to just not have that service available on one link so that the end user realizes that they've screwed up and unplugs a device and moves it around. So basically, this is not a solved problem. Like, we didn't come here with, we did come here with somewhat solved problems. We think we have a decent solution. It would be really great if the IETF could tell us if it's a bad solution in some way. But this particular problem is not actually solved. And as I said, there's basically two ways to solve it. One of them is to actually make communication work either through the stub network or around it. And the other is to just say, well, this configuration doesn't work, so we're going to detect it, and we're going to disable stub routers that are connected to one of the two networks, so that there's one network where everything works, right? And so, and the end user isn't confused. The main goal is to have consistent behavior. Does that answer your question? Okay, well, so this is a question to he shook his head. This is a question that we can discuss at length if we have a working group.
Or like we have some time at the end of the presentations to
yeah.
have a longer discussion. Thank you.
Absolutely.
Stuart, go ahead, please.
Stuart.
Yeah, I'm Stuart Cheshire from Apple. Ted presented a fairly generic overview of the problem statement, which is appropriate for this IETF work. But some people like me get their head around things better if we have a concrete example. So I'm going to try giving a concrete example, which is the genuine reason we're here today, because we have been working on home automation with HomeKit and now the Matter protocol from CSA. We've also been working with Thread, which is a low power, low speed wireless network suitable for battery powered devices. And if you look at how home networks have evolved, we started off with a PC with a modem, and then we had Wi-Fi, and we had, maybe a PC and a laptop. And at every stage, the easiest solution is just to add one more device to the Wi-Fi network, and the whole home is a big flat broadcast domain. And last time I checked, I have a little over 100 devices on my Wi-Fi network, and they're all talking to each other with multicast DNS, which means all these devices are being bothered by multicast packets saying, are you the printer? No, I'm not the printer. Stop asking me. And as the inventor of multicast DNS, you might be surprised to hear me standing here saying that, but multicast DNS was designed 20 years ago when you had a dozen things on a home network, not 100. We knew when we started that that was not the final solution. That was just one step along the journey. So putting ourselves in the shoes of a product maker today, if you want to make a smart home light switch, you can have it on Wi-Fi, you can join the Wi-Fi network, you can be part of this big flat broadcast domain, discovery works, one-hop unicast communication works, and the customer will probably be happy and not return your product. When we wanted Thread, which is much lower power and much more appropriate for battery devices, do we want to do the same thing? Do we just want to bridge the broadcast domains and flood all the traffic in both directions? Well, Thread is a 1/4 megabit network, and Wi-Fi is hundreds of megabits. Continuing to make a bigger and bigger broadcast domain in the house is not scalable. So that's what led us to this work. Is we're the IETF. We do routing. We have an inter-network protocol, not a LAN protocol. This is not NetBIOS. This is not Novell Net, where we actually have structured IP addresses and routers that forward packets, and most home users are making no use of that. So can we make products that can be sold into people's homes that will work 99.9% of the time, so they don't generate expensive product returns, without assuming that the customer changes their home Wi-Fi, changes the home gateway, understands anything? They just plug these things in and they automatically configure. We have done some work in that direction, and we have some solutions, but the reason we're here is we don't know for sure those are the best solutions. We think the work we've done has broader applicability than just this narrow use case of Thread. And at the same time, the expertise at the IETF can help us spot mistakes and do something that works better for all of these scenarios. So if anybody thinks that this is some abstract academic exercise we're doing, it really isn't. It's trying to clear the way for companies to make products that they can sell and not lose money on the returns and have happy customers.
Right. Thank you, Stuart. Eric, go ahead.
Eric Klein, Illyria. So staying on the slide, but referring to something you were talking about earlier, the universe of things that any work, a chartered working group might do that's out of scope is changing anything that's in the home, you were saying. Is everything on the table for the stub router? Can we specify that it must have a satellite interconnection or something? I mean, I'm being
I don't know why you'd
obviously
want to, but
facetious, but like, or are we going to discover that there is some install base of stub network routers, then they themselves cannot be changed, and that will also constrain the work that could be done?
so I don't think, you know, I would be a little bit surprised if we wandered far from the solution that we already have, but if we did, I would hope that it would be for a good reason. And so that would imply that what we're producing is better than the solution that we came up with on our own.
So,
And
slightly
if
more
that were the
concrete-
case, then I would like to see the better solution deployed in those existing routers, which are all running firmware that can be updated automatically. So
slightly less facetiously and slightly more concretely,
Yeah.
it would be okay to mandate an MDNS proxy in these things. To say
I mean,
you
speaking as an MD, speaking with my MDNS hat on, I'd say hell no. But yeah, yeah, in principle, like I would not be participating in that particular consensus.
Okay, all right.
But yeah,
Such a
obviously
thing-
this is the IETF. I mean,
Such things could be on the table. So we do
Yeah,
have
absolutely.
the right. Understood. Thank you.
Thanks, Chad.
Pascal, go ahead, and
Oh.
I'll take Besset. Pascal is in line remotely before you.
Pascal Toubert
Pascal
is
is
in
in
line, and
line.
then you'll be next.
Is what? I'm the
Pascal
last-
is next, and then you.
Sorry?
Pascal first.
Okay.
Pascal is in line before you.
Yes, hello, Ted. You and others mentioned a lot the IoT, and effectively, this is a kind of situation that we've been discussing for many, many years in the IoT working groups like Cisco and Cislo and RAW. And for most of the case we've been looking at, we did either routing if we go deep, and that's not what you're after, or we did, if it's just one hop or two hops, but we have a clear structure, we did ND proxy. And what we did not do is create more than one prefix. So what I'm interested in, and I want to understand here is it out of scope to maintain the same prefix on all those links, or is it okay? I mean, I understand we want to the broadcast domain, that's fine, but ND proxy can be your friend in this situation otherwise.
Right. So we looked at that. That was definitely an option, right? Because there was already when we started this work, there was already an IETF document that described a backbone router that used ND proxy. So we're totally familiar with that work. The reason we chose not to do that is because it's not scalable. At least that was our belief. So the nice thing about routing is you advertise a route and it's very simple. The nasty thing about ND, so consider, for example, this topology. So we have ND proxy. That means that now these stub routers both have to have the same neighbor table. They have to somehow maintain that common neighbor table. And we need to be careful that we don't do a lot of excess multicasts. So we want to, because I mean, we're talking about devices, like the devices that you can currently buy that do this are things like HomePod minis and Apple TVs, and I know Google has a couple of Wi-Fi routers that do it, and Eero has some Wi-Fi routers that do it. And also there's a company I know of that I think has it in their light bulb. So that means you could have actually quite a few of these stub routers. And so we need a technology that's going to work in that situation. One option would be to just say, well, okay, all of the stub routers will elect a stub router that will actually do the routing. That sort of solves the problem, but then you don't have redundancy. You could do that, and then that makes the neighbor discovery problem a little bit simpler, but it's still got scalability issues. And I think for like a network with 30 devices, it's probably an okay solution, but we were trying to think like, what do we want to have happen in the long term as opposed to what do we want to have happen in the short term? And so that's why we went with the routing approach as opposed to the ND proxy approach. But certainly the ND proxy, like it could be that the working group gets together and is like, oh, well, actually ND proxy was really the right solution. In which case, we'll wander off and that'll be what gets published, and we probably won't implement that. But that doesn't mean it's the wrong answer. So I certainly encourage you to advocate that use case if you think that's a better answer. But that's our goal is to come up with the best solution that can actually be deployed, as opposed to to insist that we're right or something like that.
Thank you. Thanks, Jed.
Behcet?
Basit, go ahead, and
Okay.
then we'll take GNY from the remote mic.
My name is Bechet Sarikaya. Yeah, Ted, my question is, you must know these Google Wi-Fi boxes. So if you have a large, I don't have a large house, but if you have a large house, why don't you buy several of them? You put one also in the garage.
Right.
And doesn't that solve the problem?
Yes, yes, exactly. So I mean, the good news about this topology, as you're pointing out, as Bechet is pointing out, the good news about this topology is that it usually doesn't happen anymore, because normally nowadays people have mesh routers. And so, for example, I have this exact topology in my house, except that the internal router in this case is an Eero. And so it's just bridging between the home LAN and the garage LAN. And so those are a single LAN. And so we just don't have an issue with this particular problem. This particular use case really, in my home, it's actually this use case, because the home LAN is yes, it's more than one. There's more than one Wi-Fi access point, but they're all in the same broadcast domain.
Thank you.
Thank you. Janway, go ahead, Michael, if you can go to the mic next. Janway?
Can you hear me?
Yeah, we can hear you, Janway.
Yeah.
Go ahead, please.
Okay. I see in the greenfield example why we can require changes to the host. Because I think the host may be the general consumer devices and is installed the common operating system such as Linux, Mac, or even Windows. I think make some changes to the hosts is very hard. How do you think?
Yeah, so that's why we distinguish between the ordinary use case and the greenfield use case. In the greenfield use case, we're assuming that the host doesn't actually have a way to solve this problem yet. And so if that's the case, then it doesn't matter if we change it, because we're always going to be putting a new implementation requirement on the host. But in the ordinary example, it's probably not reasonable to expect. Basically, what's going to determine whether the manufacturer implements these changes is whether they benefit from implementing these changes, right? So in the constrained network example, we're talking about a totally different network environment with new devices that haven't been sold on the market before. And so, yeah, it's exactly the same amount of work to add this new functionality to those devices as it would be to add them to like an iPhone or something like that. But the difference is that the manufacturer of the device that's going to connect to this greenfield network is motivated to do that. And the manufacturer of the device that's going to connect to the ordinary network is not motivated to do that. And so that's why I say that in the greenfield example, we can require changes to the host, whereas in the ordinary example, we can't. It's not because it's easier in one case than in the other.
Thank you. Michael, go ahead.
So I think that also that question, and Eric asked that question, can we assume that the routers the stub routers are greenfield? And I think the answer is yes. And you had some well, maybe blah, blah, blah. But I think that we can assume that we can do anything we like, as Eric said, including adding a satellite or a loon connection to them,
right,
if that's what the working group consensus is.
Yeah.
But I want you to go back to your slide with the double stub, that one. Yeah. No, yeah. No, that one. Yes.
Yeah.
So I actually think that it's quite reasonable that we do some kind of election on them, as long as we do it on the stub network, not in the other network. And I think that should be something that we should think about. But and I know you know this. So the situation where people would put this kind of scenario is one where they have a smart speaker and they want to have one in several rooms, and they don't always have connectivity from the upstairs to the downstairs, and sometimes they do, and sometimes they close that metal door, or the door that has metal in it, and the stub network partitions.
Right.
Okay, and so those partitions are completely random, right? You let the cat out the door, up and down.
Yep.
The network reconverges for 3.5 seconds,
yep,
and then partitions again.
Yep.
Right. And sometimes you leave the door open all day.
Right.
Okay. Or sometimes you have I've heard that a tinted windows, that change based to keep the sun in and out, that they're really good at reflecting EM waves around corners. But when they're clear, letting the sun in, they don't reflect things,
Ruining everything, yes.
Yeah, so the point is that stub network is just a mess of things, and that's why people want to put multiple stub routers, is so that they can have connectivity to all these other low power devices, and they want to use the homeland as a backhaul,
right?
Much like Pascal has described. And so, there's a bunch of different options, but basically we're trying to just keep the network going.
Yes.
That's what it really amounts to, right?
Yeah.
Hi, Philip Teasel. So if we are talking about scoping of this potential working group, my question would be, what network technologies do you think of in the stub network? So if you're thinking that it's Ethernet like most networks today, this is certainly easier if you envision something like 6LoWPAN on a stub network.
Right.
And so is there already an idea of how we want to scope that?
So you want me to take this? Yeah. So like Philip, that's like really open to discussion, right? So that's something we can there is like a proposal for a charter that like Ted put up, but that's something that's open to discussion today and like further on the mailing list as well. So that's we should be flexible on that. Thank you.
Yeah.
Thanks. So thanks a lot, Ted. I think we exhausted the mic line, and thank you very much for doing this well. Jonathan, please.
Right.
What I haven't seen on these slides is any kind of analysis that says, okay, we think A, B, and C might be reusable here, but gaping holes are D, E, and F.
Right. No, and thank you for bringing that up, because unfortunately I made these slides in more of a hurry than I intended to, and I didn't think to hit that particular point. Yeah, so it would be really nice if this were just like RFC 7084 for stub networks. I don't think that we can quite do that, but definitely, certainly when we did the thread border router implementation, and I think, my hope for this working group would be that this is the case here as well, is that we didn't want to invent a whole new protocol suite, right? The goal here is not to create something like HNCP for stub networks. It's more to say, like, here's what you need to do with RAs to make this piece work. Here's what you need to do with neighbor discovery to make this piece work. That's what I think we're going to wind up doing. That's what we did with the thread border router. Whether I'm correct about that is something that we need to talk about. So, and I said deliverables was just the solution, but actually you raise a really good point, which is maybe we actually should have some more analysis before we do the solution document. Yeah. Yeah.
are we doing actual new protocol design? Or
Yeah.
tweaking how a protocol is implemented? And by the way, if we're changing how router advertisements work, shouldn't that work really go back to that IPv6 working group?
Right. So
So that, a document like that
yeah.
to be really useful.
Yeah,
So you might want to read the draft Lemon problem statement, subnetworks problem statement document.
Well, I did in fact
Okay.
skim it, and I guess I didn't come away with a crisp understanding
Fair.
of what the deliverables for the working group might be
Yeah.
out of that.
Okay.
Yeah,
So-
thanks, Rand. Like, can I just add something? So there is like a proposed charter that was discussed on the mailing list. So we just threw it up. So in a roundabout way, it covers like what you want to cover, but maybe it can be made more crisp. What it says is like, these are the functionalities that are required. Like, so that in the stub router, that's in the charter and the deliverable. And there's a non-goal in the charter. It says like, we are going to try to use existing protocols as much as possible, right? So both of these together read into what you say, but maybe we can make it a little bit more explicit, saying that, hey, we are trying to not reinvent the wheel as much as possible here.
Yeah.
It seems to me that if we can reuse technology,
That's absolutely that's A, what we did, and B, definitely the goal.
Thank you. Thanks. Jonathan, please come up.
All right. Can people hear me? Okay, there we go. Yeah, so I'm Jonathan Hui. For those of you who don't know me, affiliated with Google. I'm here to present a concrete use case of the work that we're trying to drive forward here within the IETF, which both Stuart and Ted have already kind of highlighted or previewed in a few times already. But just to make it more concrete for people here, especially those that are not involved with Thread. Next slide, please. So what is Thread? Next slide. So I think Stuart already mentioned this. We like to think of Thread as a low power alternative to Wi-Fi. One of its target application layers that it's supporting is this protocol called Matter. Matter is an IPv6 based application layer, and it's intended, at least in its initial version, to work across both Wi-Fi and Thread. Thread, supporting low power battery operated devices. And the intent there is for Matter to work seamlessly end to end, right? Just using IPv6, whether it's Wi-Fi or Thread. Next slide. This data is about 6 months old now, but this is the last time they've publicly provided any data on the number of devices that are, coming out with Matter by the end of this year or early next year. But there is 134 devices that are currently implementing Matter and going through testing from about 53 different companies. That is the largest test event that CSA has had, and about half and half is the split between devices that support Wi-Fi and devices that support Thread. Next slide. But even though I am talking a lot about Matter, I want to stress that Thread is a generic IPv6 transport, right? The goal here is to provide, IPv6 connectivity to any set of application layers and having them run simultaneously, right? We really do believe in that vision where IP is the convergence of a multi-service network. So, we have existing products that are being delivered using Weave, which is a IoT application layer for Google products. HomeKit, as was already mentioned, is already shipping with Thread as a link technology. And then looking forward a little bit, Matter I already talked about. KNX is a building automation communication technology. And then Dolly is a commercial lighting communication technology, which have also both announced that they will be bringing Thread to their solutions in later this year. Next slide. Yeah, just real quick, the key points to call out with Thread is that it is based on IEEE 802.15.4, the same radio that's used in Zigbee. The PHY is the OQPSK 2.4 gigahertz quarter megabit per second data rate. The other thing to call out is the frame MTU is 127 bytes, right? So when you talk about the MAC overhead, media access, this link really is only providing about tens of kilobits per second, right, data rate. It is 6-LoWPAN based, so 4944 and 6282, using those technologies to transport IPv6 datagrams. Next slide. And then there is a lot of stuff going on within Thread, but I just wanted to call out some of the high-level properties of it, and gets into something that was already mentioned earlier in this session. But Thread is a mesh topology. Thread devices discover routes, multiple hops if they're not directly within range. And next slide. Thread devices connect into other link technologies like Wi-Fi through devices, what we call border routers. Right? And Thread was designed to be no single point of failure, and so a Thread topology can have multiple border routers active simultaneously, providing connectivity between Thread networks and non-Thread networks. And to really, this is a concrete problem, right? These are products that are shipping today. They have been shipping in some cases for multiple years. I think best answer is we have about tens of millions of these devices total deployed already in market, that have 15.4 radios in them, and have had announcements that they will be upgraded to Thread, the latest version of Thread to support Matter. But in many of these cases, they're already running some version of Thread already. Next slide. So yeah, we talked about what's the topology look like from a stub networking perspective. So even if you look at a single thread network, right, as Michael talked about, that thread network may appear as a single cohesive topology, may appear as separate, physically connected topologies, because just the way the radio connectivity works. And so it could be that the border routers are servicing the same mesh topology and are connected through the stub network, or it could be that they're only connected through the infrastructure network itself. And this is dynamic, right? This device may come and go. There may be other, the steel door opening and shutting that is affecting this connectivity. Next slide. Yeah, so dynamic merging, right? If connectivity comes back, then those stub networks can combine into a single stub network. Next slide. Next slide, please. Thanks. All right, next slide. So Stuart mentioned this a little bit already. With the home network that we're used to today, it's a single broadcast domain, all devices connected within a single IP hop. Next slide. But when we look to attaching a thread network, we don't want to just bridge that network, right? It is a highly constrained, low data rate network. We really do want to isolate all of the multicast and other traffic that's happening on the Wi-Fi from the thread network. And that's why, with Thread, so far we've chosen to have that connected in as a separate network.
Jonathan, I think Ran has like a clarifying question.
Oh yeah, sure. Yes. Yes. Yes.
Sorry, we cannot hear whoever is talking right now.
Sorry. It No, so
Jonathan, can I just
Yeah,
because I think there might be some audio issue. So if I can summarize Ran's question quickly. So Ran was asking this purple pentagon that's in the picture, why doesn't it have a Zigbee radio? Would that be a fair summary of your question, Ran? Ran is shaking his head for the people who are remote. Thank you.
Yeah, that's fair. So I'll just bring it back to this. Sorry, I lost it. I'll bring it back to this slide. So the answer is it can, right? So these products here, this is a Google Wi-Fi access point. These are Eero access Wi-Fi access points. They do include thread radios, right? Not every access point includes a thread radio today, maybe tomorrow if thread becomes pervasive, but we have to assume that in some networks they do include a thread radio, and in some networks they don't. And so you do see a lot of other products that are not your Wi-Fi access points, right? That allow users to easily add thread to their home without having to swap out their Wi-Fi access points. Yes.
It got turned off somehow. So Ran, let me put that question back to you, if you're listening. Hello, Ran. I'm answering your question. So I wanted to answer your question, Ran. You asked, why doesn't the home gateway have this $1 radio in it? My question to you is, does yours at home right now? You want to buy a $5 light bulb, which you're told you can control remotely. You take that light bulb home. Does your home gateway have a Zigbee radio? Yeah. Okay. Is that a safe assumption for a product maker that every customer they might sell to has a home gateway that does that?
I'm suggesting that there are more topologies than have been shown here. And one of the obvious long-term topologies is that the Zigbee radio goes into the cable modem or the DSL modem or the whatever that is also the IP router that is also the Wi-Fi thing. I think that's an inevitability. That's not a short-term fix, but it's a topology that the group as a whole ought to be thinking about, right? Right? There are going to be a lot of topologies, but that's one of them.
That's represented by these products here.
Yeah, so let me just reiterate something that Michael said earlier, which I think speaks more
Ted
to your...
Lemon speaking.
Oh,
for
this
the
is Ted
people who are
Lemon,
remote.
sorry. Yeah, so something that Michael said earlier, which I think really speaks to Rand's question, is even if your router has that device in it, that doesn't fully solve your problem, because what if some of your mesh devices are not close enough to that router and not close enough to any other mesh device that they can reach that router through either through a mesh device or directly? And if the answer to that is no, then you probably need more mesh routers than just that one. And so that's part of the idea with the thread mesh certainly is that it's a self-healing, self-managing network that works even if you have gaps in physical connectivity, as long as you have devices connected to the backbone that are also connected to the thread network.
Michael Richardson said, even if you're having a dispute with your ISP, for the people who are remote. Thank you.
So I do want to be clear that I'm not disagreeing with Ran that it would be lovely if that purple pentagon, the home gateway that the customer already has, their cable modem, whatever it is, be wonderful if that had a thread radio in it as well. Ran says his already has, and I'd love to hear from him afterwards what product he's using, because I'm not aware of any such product. That would be wonderful, but it is not the reality today, and it's not going to magically happen overnight, because if nobody can sell thread light bulbs because no customer can use them, then there's no market for that. If there's no market for that, why would any cable modem vendor add this capability that no customer's asking for? This is always the problem in networking, is the chicken and egg problem. So we need a transition that gets us to this glorious future where every home gateway has thread. I'm sure Jonathan would love to see that. We'd all love to see that, but we need some way to get from here to there.
Thank you. Go ahead, Chris.
Chris Morrow. Some of the problem here is that there are multiple different transport layers, and they may or may not exist, and that a single device may have more than one transport link. And it doesn't matter what the transport is really anyway. It's the upper layer protocol that you care about. So I think describing the problem in that way, as opposed to letting people infer it. I think Rand's comment about like, oh, why doesn't it just have the right radio? Okay, I have a new radio. Does it have that one? No. Right? That's not the problem. It's not the radio that's the problem. It's multiple links.
That's right. Yep.
Thank you.
Thanks. All right. So The next set of slides here, I just wanted to give a little bit of preview, and this is really talking to some of the stuff that Ted and Stuart were mentioning into, you know, this stuff is shipping today, right? And so what do we decide to do right now, right? So one is, you know, how do we provide IPv6 reachability in thread border routers? So the first step really is to configure the networks with the appropriate scope IPv6 addresses, right? Link local addressing doesn't work. Is not sufficient for Wi-Fi devices to talk to thread devices and vice versa. Right, so one of the actions of the border router really is to, one, discover whether or not there is a usable prefix available on that link. And if there is not one, then it has to go ahead and configure that. And how does it do that? Well, router advertisements with prefix information options, right, on the Wi-Fi side. Thread has kind of a analogous mechanism, but we don't need to get into the details of that there, but you can think about it as just configuring a prefix with the appropriate scope. And it is a ULA, right? So it locally generates that at random and then advertises that in a router advertisement. Now, once it has appropriate scoped addressing, then it has to also advertise the routes so that devices on the Wi-Fi side know how to access devices on thread and vice versa. And so how does it do that? Well, it uses router advertisements with route info options inside of it, right? So all existing, you know, encodings that are already defined in RFCs. But, you know, as Ted mentioned, I think some of the behaviors of how do I detect whether there's a usable prefix? When do I generate a prefix? If I have multiple border routers, how do they, you know, coordinate or, you know, figure out rather than having everyone generate their own prefix at the same time, right? So some of that behavior is not really defined today, right? And that's kind of some of the stuff that we had to do in the thread border routers for this to be scalable. Now, we also talked about DNS Service Discovery. So this is really just pulling on a lot of the work in the DNSSD working group, right? We wanted to avoid MDNS because multicast is expensive and thread is a low, you know, low bandwidth link. And so, you know, how do thread devices publish services that they offer? So in thread, we use SRP. And in SRP, it's just a unicast update to a thread border router. That thread border router implementing an SRP registrar. And the thread border router uses that SRP database along with an advertising proxy to make those services available, discoverable on the Wi-Fi infrastructure link, right? And so in that case, the Wi-Fi devices continue to use MDNS to discover services published by thread, but that multicast stops at the border router and doesn't go into the thread network. So how do thread devices discover services on the Wi-Fi side? Rather than using MDNS directly, they can send a unicast DNS query to a thread border router, and then the border router implements a discovery proxy, which translates that into an MDNS query on the Wi-Fi side, you know, gets the response, and then provides that in a unicast response to the thread device. So again, avoiding all of the multicast overhead that's on the thread side. Great. So yeah, it was intended to be really quick, but also provide some more concrete kind of background on thread and why this work is important to thread.
Thanks a lot, Jonathan. Yeah. Thank you very much for coming and sharing the thread use case. Thanks a lot. Michael, whenever you're ready. Thank you.
The X. Stand on the X. So do we now have it all? We still don't see the remote people, right?
Nope. They're going to fix it after
They're
the
going to
session.
fix it afterwards. Okay. Hi, my name is Michael Richardson. And
Michael, just
yep.
Pascal, did you have a question for Jonathan? Or if you have a question for Jonathan,
yes.
Go very quickly. Yeah, thank you.
Go ahead.
Yes, I had one question. Is it okay that I ask it?
Yeah, go ahead.
Okay, hi John, great to see you again. It's been a while, so very happy to see you there. My question was about the networks joining and splitting that you've shown on one slide. And remember, there was one where you could see two groups and this isolated guy in the middle. I don't know if you can bring back this slide. Or maybe it's too late. But basically, what you've done for service discovery is exactly the way we do as well for ND proxy, because I mentioned ND proxy earlier. So this exact system that you explained for service registration is the way 6LoWPAN does also for addresses. So that's how we maintain a single prefix across the Wi-Fi backbone and the multiple, not thread, but multiple IoT networks. And the reason we've been doing that is because of joining and splitting of the network. So there is another slide, actually. It's not this one, it's before that one. It's a slide where you could show that the thread network was actually split.
Yeah, it's coming.
And my question here is basically this scenario. It is the one that we looked at 6LoW for large factories with thousands of nodes and multiple of those gateways, and the nodes possibly moving inside the factory, and we did not want them to remember, and so that's why we ended up doing the ND proxy. I see that this year. We ended up doing the ND proxy and routing inside the stubs, and you're well aware of that, Jonathan. I'm just wondering if you're doing a different routing well, not different routing, but different addressing in the two stubs when they join, split, and do the node have to form new IPv6 addresses depending on reachability to gateways? I mean, how does that happen?
I didn't actually hear the question very clearly.
Oh, okay. So I was saying in a case like this, the reason why we did proxy, we discussed earlier, is because we did not want the devices to remember. That's really the reason why. And so there is, in the usual 6LoW networks, there is a single prefix for the whole thing. So the guys can move to the left, to the right, etc. And the question to Jonathan, since in Thread they are apparently creating a new prefix inside each stub, what happens when the stubs merge, join, people are more on the left or more on the right? Do they have to renumber? I mean, how does that work?
Yeah, so indeed, if there's a network partition, then renumbering is going to happen.
And not moving, right? I mean, it's not, I mean, partition is one thing, but basically nodes moving. Say this is a big factory and there are robots throughout the factory. And they are moving with their devices, crossing, going left, going right. And the shortest path to the Wi-Fi infrastructure is sometimes through one gateway, sometimes through another. And having to remember is kind of impractical in that space. I mean, that was what our
Pascal, this is Ted Lemon, by the way. Pascal, that that particular question that you're asking, I don't think is actually as interesting a question as you're suggesting it is. And the reason I say that is because what you in a mesh network, the mesh topology is gonna change as the robot's moving around, which isn't ideal actually, but you can't really avoid that. And so in that case, the robot's not going to renumber. It's going to keep the same IP address the whole time. It's just going to be in a different place in the mesh topology.
In either case, I think it's not a clarifying question for Jonathan. So if you want, we can discuss this a little bit later, but I kind of want to have Michael talk about it, so we'll have some time for discussion at the end. Thank you. Thanks, Jonathan. Thank you. Thanks, Pascal. Pascal, if you have like unresolved questions, we can take it up in the discussion time. Okay. Thank you.
Hi. I think that the problem is that we're using this laptop that's supposed to be projecting something, but we're doing it wrong.
If I do it from here, like, that didn't show up. That was the issue.
Oh, I see.
Wrong.
Okay. So hi, my name is Michael Richardson. So I'm going to talk a little bit like about a kind of alternate use case that, and I'm going to say we came to it backwards, where we were looking at the solution and going, I wonder if it would work here. And then so we decided we better explain what here was. Um, the other interesting thing about this was that some of the requests that came internally were some of it got lost in translation, and we went back and forth a bit, and finally realized what their actual problem was. And then they actually said, oh, internally they said, well, actually, this was what it was, not the thing we were thinking about, several months ago. So that was kind of a weird learning process. So basically, what we're talking about is buildings, and I kept wanting to put in Die Hard pictures in the middle of this because it's one of those cases where what was science fiction scenarios from a movie, and you suddenly realize you're implementing it, right? It kind of seems silly. So you imagine, you have these buildings, and they have a number of different systems, and they all converge in one of those, security rooms, which is where, of course, you take over. If you're going to take over the building, you take over that room first. And they have all these, different systems. And one of the reasons why they have different systems is because they bought them from different vendors over many different years, and they can't get any of their vendors to talk to each other regularly. So they have all these different networks, and they all come back, and essentially there's an application layer firewall between all of them, which is the human that pokes things, right? There. So everything's great, and they have a lot of wiring and a lot of expenses until that part of the network goes down, right? Due to malfeasance, fire, or just incompetence. And so then, there's a problem, and there's false alarm issues and other kinds of things. And yet all the equipment is out there, and the people would like to maybe be told if they should go up a floor or down a floor, or where's the fire, or is there a fire? And it wouldn't it be lovely if instead, the devices could talk to each other. We could have some kind of a converged network that would work even in the absence of a brain, right? And so in that sense, it looks very much like the home network situation, because in this case, the brain is the ISP who runs the home router. And if to Rand's question, it's because I don't want to use that router because it belongs to the ISP, and when they replace it, I'll lose all access to all my light bulbs. And that's why I don't want to do that. But so the ISP has no brain, and they won't participate in this network that I want to build and I want to own. And that's why we need gateway to gateway communication. And then building, it's a similar thing. It's just that the brain's been disconnected because, I don't know, floor number 7's on fire and all the cables in the fiber melted, right? And the people above that floor would like to know what they should do and what's going on and all this stuff. And so this is the kind of thing that we're having the conversation about. So built a little bit of a diagram of how I would build a network in a multi-story building. And I've had a couple conversations with people that do building automation. And it's interesting that a number of people, when I asked them about the physical network things, they said, well, that's a really good question. I have no idea how it's actually physically deployed. And I went, really, that's really startling. You'd think that would be a critical part of the security posture to know what the resilience is. And they said, that's a really good point. Why don't I know this question? And I hope we'll have more information in the future. This is what I would do, right? I would put a 4-port router on every floor. I wouldn't want to wire it all back to the thing. You have Ethernet, length limitations. There's a lot of, if you think about a 40-story building, or even this hotel is about 23 stories, right? The distance from the top floor to the bottom, it's way beyond copper Ethernet length. So you have to go fiber, and in some cases, once you go up and down all the different things, it's more than 2 kilometers, and so you wind up having to use, not just multi-mode fiber, but single mode at greater expense. So that's silly. So you put it together, and what do? Well, you could run a routing protocol, and we have a whole bunch of them. We actually think Ripple actually would be really good, but I think you could do with OSPF. I think it would be annoying because you'd have to think about exactly what you're doing with the areas. I think that if you threw this at a typical vendor, they would say, oh, let's do an L2 Metro Ethernet solution. Put it all in one L2. That's the home Wi-Fi network. Everything's bridged. And then they would think, okay, but now I have all this sensor network behind each one, which is probably 802.15.4. It might not be thread. It might be BACnet as well, depending on what devices and the age of the building. And then they would say, okay, but now I don't have Ethernet on both sides, so I have to do routing. So suddenly it looks exactly like the diagrams we just said. We have these gateways, they're connected together by a complicated topology, and they would like to do things. Particularly, you would like to have sensors on one floor, or actuators on one floor, talk to sensors on the adjacent floors, right? Don't open this door up or down stairwells if the one above it or below it is full of smoke, right? That would be a bad thing. Tell people, I'm not opening this door because this is not a good exit. Go the other side of the building, right? Something like that. So, you know, something goes bad, some floors are on fire. What are you going to do? Okay, so there's some differences though between this network and the home network. One of them is that there is an operator, they're just absentee at this time. So they could set up credentials and they could set up configurations and they could allocate prefixes. But when the network event happens, you can't do anything else. Those machines are not accessible. They have to have their own intelligence. And we're not necessarily talking about, you know, AI vision systems. It may just be stupid things like, as I said, don't open the door if there's smoke on the other side. But, you know, those things have to run that way. So it's a little bit advantageous versus the home in that someone can actually do something intelligent beforehand, but they can't do anything intelligent during. That's really it. So this is neither here nor there. It feels like a solution that could use the same solution that Ted has proposed. On the other hand, there's a lot of other things that we could do. And I've only really talked about the L3 part, the layer 3 part of it. There's a layer 4 to layer 9 problem. And we're having a side meeting tomorrow evening. And then we're going to walk over to the social event. Come if you want to talk more about that. Thanks.
Thanks a lot, Michael. We don't see anybody at the queue, so we can just like move on to the open mic discussions. So anything that's been presented till now is fair game and doesn't necessarily have to be clarifying questions, pretty much anything. So Stuart, go ahead.
Yeah, I'm Stuart Cheshire. Just a quick comment on the thing that's been raised a couple of times about proxy ND. Certainly that can work. The thing that makes me uneasy about that solution is it seems like the very easy solution when you just want to add one more thing to the network, just make the broadcast domain bigger and bigger and bigger. And it's like the silly example people give of boiling a frog. Just you incrementally add things until the thing doesn't scale. When people talk, at its heart, what proxy ND is doing is making it look like all these devices are on a single Ethernet. And that is great for the IEEE, but this is the Internet Engineering Task Force, not the LAN Engineering Task Force. And something feels wrong if we're rejecting everything about internetwork protocols and building everything using a sort of 1980s LAN style mindset. Let's just build a LAN. And one of the examples was given, like, what if you have an enormous factory? If I have an enormous factory, having that be a single LAN seems like a terrible idea. It's rejecting the whole insights of having an internetwork protocol, not just a LAN protocol.
Thank you. Thanks, Stuart. Pascal, go ahead.
Yeah, there is a big misconception here, Stuart. I'd love to speak with you offline. We explicitly break the broadcast domains, right? The goal of doing ND proxy is to do separate broadcast domain. And the whole work at 6LoW for more than 10 years, pretty much 15, has been to avoid the broadcast. So effectively, we've designed the routing protocol when we need a routing protocol, and we are doing ND proxy when we need ND proxy. It's a matter of having all the tools in your toolbox and finding the tool that you want, but all the tools separate the broadcast domain. There is never this conception of a single broadcast domain the way I kind of understood you presented it. This is the thing that we want to avoid. So on that we agree. Basically, what you've seen Jonathan presenting about service discovery is the way we do ND as well. Both service and ND, everything is done that way. We don't have a choice. We don't have broadcast.
So
Go ahead, Ted.
yeah, so I'll just speak to Pascal's point because I happen to be here, but that wasn't what I came up to talk about. The problem. So if you look at DNSSD, which is what we're talking about here, what's nice about DNSSD that is not true of neighbor discovery is that proxy neighbor discovery, I should say, is that we can replace multicast DNS with unicast DNS. We don't really have a way to do that with neighbor discovery. So there's always going to be a certain amount of multicast if we're doing neighbor discovery. And as you add more hosts, you get more multicast. So, you know, it's certainly true. And I don't think that anybody here is criticizing the solution that you've generated for the factory floor. But we were trying to come up with a solution that didn't have the scalability issue that I see in your solution at all. And I do see that there's a scalability solution as the number of neighbors on the network grows. That's clearly a scalability issue. Whether it's a big issue or not is a matter we could debate, but it's definitely an issue. So the point is that our sort of, you know, in the DNSSD working group, our path forward is to try to get as much away from multicast as possible. And that creates efficiencies that you just can't get with if you're doing everything with multicast. So that was an answer to Pascal's point, which I think that's a good thing to discuss. But the thing that I actually came up to do was relay something from somebody who sent me some private email from Eero, who was just asking, like, does the stub networks problem relate to virtual networks? So if you have virtualization on a device, could SNAC provide a way for virtualized devices to access an infrastructure link or the internet? And I think the answer to that is yes, and we should probably factor that into our use case discussion.
Okay, perfect. Thank you. Thanks. Matthew, you got into the line and got out. Is that something you wanted to say, or? Go ahead, Matthew.
Can you hear me?
Matthew, we cannot hear you.
Hello? Can you hear me? No?
Yeah, you're coming out very low, but yeah, if you can speak up a little bit, probably.
Sure. Hi, I'm Matt Richards. I'm at Eero, a subsidiary of Amazon. I just wanted to just talk a little bit about, you know, Eero, or Amazon through Eero has been kind of participating in some of the thread and matter work. We brought up thread on our Eero home Wi-Fi routers, and just, you know, very interested in kind of seeing where this SNAC working group goes. I think this is a pretty interesting problem that has a lot of kind of similarities to the, you know, mesh Wi-Fi work that we're doing, and just very excited to see us not make some of the same mistakes, I guess, specifically around large multicast domains. Just hopefully just kind of excited for this this problem statement to really get a thorough investigation and see what comes out of this. Thank you.
Thank you. Yeah, just go ahead.
Hello, sorry, Richard Patterson from Sky UK. More for Ted question, I think. So all of our CPU routers in general these days kind of operate with a very clear like distinction between LAN side and WAN side, or trusted versus untrusted. Do we see SNAC trying to get these things to fool themselves to work out how to get through that sort of security zoning, like pinholing through, or do we want to see them auto detect and it's now no longer LAN and WAN, it's trusted and trusted on both sides? Or how do you kind of foresee that?
That's a great question. So, I mean, clearly, you know, if we say that hosts on the stub network need to have equivalent functionality to hosts on the infrastructure network, then our expectation would be that the router, the customer edge router, would be responsible for doing, you know, RFC 7084 style firewalling. And I think that's sort of the lazy answer to your question. I think that there's some interesting work to do there. It's not clear that the SNAC BOF is the place to, or the SNAC, whatever working group we come up with, is the place to do that, but it's certainly something that we could consider putting in the charter, I think, if we thought it was worthwhile. Because clearly there are cases where it makes sense to isolate things, right? You don't want necessarily to have every device be able to talk to every other device on your home network, because, you know, we've seen examples like with the Mirai botnet where that was really bad. And so being able to control that might be interesting. Whether this is the place to do that, I don't know.
Thank you. Thanks, Jim. Pascal, go ahead.
I just wanted to reply to Ted, because he was talking a lot about multicast and large multicast, etc. I mean, again, that's the thing that 6LO avoids, right? I mean, so you need to look at how we did things. We build networks with tens of thousands of nodes on the same /64. We build them, we deploy them. Sometimes we have 20 hops in those networks. And they work over the exact same radios that, well, not exactly the same, but very close to the one that Jonathan has been talking about. And we combine effectively routing and unicast ND, because the whole ND is done unicast apart from either RS or RA at the beginning. So you have to look at beyond the ND the way you knew it 20 years ago. That's pretty much my answer. I mean, we need to be honest about what 6LO has, and 6LO builds, and Ripple, we build those tens of thousands of devices networks. So we scale. Don't throw scaling at us.
So I probably owe you an apology, Pascal. I think I might have been focusing on a different question than what you're focusing on, and that might be why we're not coming to convergence. What I'm talking about is multicast on the backbone. And so I'm trying to avoid having 10,000s of devices doing neighbor discovery on the backbone. If you have a mechanism for avoiding that by doing those neighbor discoveries with unicast, then that addresses that problem. And certainly the 6LO solution, where on the 6LO network you're not doing multicast, addresses that problem on the 6LO network. But you know, for example, in the thread use case that we're talking about, we also don't do multicast on the 802.15.4 network. That's all done with, well, actually, I shouldn't say that. Jonathan might correct me on that. But the point is, we're certainly not doing individual ND type multicast on the thread network, and so that eliminates the problem of you know, excess multicast in that constrained network. But the concern, the scalability concern that I had was more for the adjacent infrastructure link, where you know, having all of that multicast on the adjacent infrastructure link can be problematic in a number of ways. One of them is the amount of multicast traffic, and the other is just that multicast traffic is not reliable. If you have a Wi-Fi mesh network, it's often the case that multicast traffic from one access point isn't necessarily 100% reliably replicated to all access points. And in that case, you wind up not being able to reach devices. And so relying on that kind of multicast isn't ideal.
Can I answer, or do we go to the mailing list for that topic? I don't want to clog the meeting, but we have answers for that there, basically. Well, let me know at the end of the meeting if I can say exactly what happens. But yeah, I mean, I won't hold the discussion. Just that it's not the end of the way. We are beyond that.
Pascal, right? Like, so I think we're kind of staying out of solution space for now, but I think it's really good to have that discussion, right? But I think as long as we agree on the goal of reducing multicast on the infra network is good enough, I think we can talk about the solutions after, right? So that'll be good. Like, so if you have time at the end of the meeting, we can do that, or we can do it on the mailing list, or we can probably do another like interim meeting or something just to tackle that. So that's certainly fair game, because we are not presupposing a solution here, right? We are talking about the problem space. Thanks. Go ahead.
You basically said what I was about to say, which is I love the excitement people have to try to solve this problem here in the room today, but that's not actually what we're here for. We're here to assess if there's interest in solving this problem.
Yeah, thanks. And I think like one of the things that I think both Stuart and Ted stated is like, hey, if there's a better solution, we want to find it, right? So this is not like just trying to rubber stamp a solution or anything. Like I think it's everything is fair game now. Pascal, thank you. Philip, go ahead. Thanks.
So, as we discussed a little bit about whether this could also be applicable for virtualized infrastructures, another question came up to me is, do we have to think in this working group about limitations and scalability based on the addressing? So in virtualized infrastructures, you easily come up with situations where you end up with saying, okay, a /64 per link. You easily run out of the number of buckets for networks in the infrastructure above. You easily run out of that. And the question is, do we also for the home network case come into a place where we, for example, have a prefix delegation from the ISP with a /56 or something like that, and we need more stub networks than that fits in this prefix delegation, and what the solution spaces for this are?
Ted, did you want to answer that?
Ted Lemon. Yeah, so that's actually a question that Jared was talking about probably a month ago when the SNAC stuff first got discussed. And you know, one of the things that he suggested would be really interesting would be to make it possible to get multiple prefix delegations from the ISP. So, you know, there are things we could talk about there. I think that there's a risk here of boiling the ocean in the first version of this process. There's, you know, if we come to a conclusion that we actually need to do that work, I think that we could probably charter it, but I don't think that we need to start with that. And I think if we start with too many difficult things, then like it would be good to like actually, you know, we should be careful not to have a solution that we know will prevent us from doing something like that, right? But at the same time, you know, we shouldn't try to solve every problem all at once. So you know.
And to be fair to Ted, like Ted did actually put up like a getting multiple prefixes in the original charter that he kind of wrote, and we kind of scoped it down because the idea is to get something that's more tightly scoped to start the work on, and then we can add deliverable. Like I think like if Eric approves, right, we can, if there's a working group, and like we can add a deliverable pretty quickly with a milestone, right? But the idea is like get something that's of like that's useful and tightly scoped, right? That's usually how we start off, right? Instead of trying to do everything at once. So that's certainly something. So we can actually add text to the charter, like to say like, hey, we should be thinking of this. And if there's interest, we can actually add a deliverable too. But that's kind of something we can discuss like in the charter discussion itself, right?
Yeah, so for this explicit question, I think, so for the cloud use cases, I think many people thinking about that ended up saying, okay, we sacrifice another holy cow and we scope down the stub networks to something smaller than /64. And so this is also something that might be worth thinking of in this context, because it might be easier than getting larger prefix delegations and updating the prefix delegation mechanism.
Yeah, I think we got it off soon. So Philip, like I think we can certainly discuss that. There is some issues with Slack on non/64s, right? So I think like, you know, Jen, six-man chair, is sitting here. So I think they're probably treading on some very dangerous territory if we start specifying it, but it's certainly something we can discuss and probably throw off to six-man at some point. Thanks.
Yeah.
Thank you.
So just to be clear, what I thought the interesting virtualization problem was you have a copy of VMware and you want your VMware host to be able to communicate equally on the link with other hosts without necessarily using bridging, not solving the whole like cloud virtualization problem, which is a huge problem. Yeah. So what, you know, and that's not to say that we can't go in that direction if it makes sense, but I think there's a very tightly scoped stub network use case for something like VMware that, and you know, not necessarily VMware, but that kind of thing, that is interesting and that might well be in scope, like right away or soon.
Refresh. Switch to the meetup on the chat from there. Yes, like except it's not showing up. Go to the tool bit on the upper right. You have to do the yeah. As Terry, you get the. No, but it's like the upload of the charter onto this, so it's just not showing up. But I'm saying it has to get imported. It's a refresh. Circle. No, I'm doing that. It's like this. I am getting it. Even roundabout way. There you go. Now it's there. Okay, so now we are at the interesting part of the meeting where people are gonna try to add things, delete things to the charter. So thanks, Jed, for getting the discussion kicked off. So we had quite a bit of discussion on the mailing list, and we hope to have more discussion on this today. The idea would be for people to have a general idea of what we're trying to solve here. We don't need to dot the I's and cross the T's, but as long as we understand what is the general problem we are working on and what we're going to try to deliver initially, I think we should be fine. So has anybody in the room not read this charter? Please hum. Okay, so we'll just go through this slowly. Tell us if you want us to slow down, but this is the initial text of the charter, so it doesn't talk about any deliverables, but it talks about the generic scope of the work you're trying to do. It's probably going to take 2 minutes for you to read. If you cannot read this, please raise your hand or come up front to take a look. And it's also uploaded in the meeting materials into item called Charter Highlighted, if you're looking at this remotely. So 2-minute time, please go ahead. And if you have any questions on the first part of the charter, which is just the background and the description of the proposed work, you can join the mic line. Michael, you're up first.
Michael Richardson. So the third paragraph, so hidden inside of this third paragraph, and I don't know whether we should change this or not, hidden inside of this is essentially the statement that if the host can connect out, that is implying that actually, double NAT it would otherwise be a workable solution if all we needed to do was have the host connect out. I don't know if we should say that more clearly, if we really need to hit people over the head that this is exactly what we're trying to avoid, or, whether that's understood by everyone or needs to be understood by everyone, I don't know, right? I mean, I guess the question is, I think the ISG understands what we're talking about when we say that without having to say explicitly, but maybe the rest of the world does not. Okay. So I just don't know if I'd fix it or not, because I know what it means, but I don't know if other people outside this room understand it.
I think it makes sense to clarify it, Michael, but I think Stuart might have a point on that. And
Well, I have a question for Ted. Do we have a typo there? In the last sentence, it says infrastructure twice. Hosts on the infrastructure network can't discover hosts on the infrastructure network. Did that mean stub network for the second one?
Thanks for noticing that. So we're talking about the sentence where it says, but hosts on the infrastructure network. It cannot be the case that hosts on the stub network can connect out, but hosts on the infrastructure network can't discover or connect to hosts on the stub network. Right. Yeah, so it should say stub network in the second. That second infrastructure should be stub. Are you editing this, or do you want me to?
I think, Ted, if you can join from Meetecho, like the full client, and you have the editable version of this, right?
Yeah, I mean, I think the link that I gave you lets you edit too.
Okay. Cool.
So, but I'm happy to do that.
Yeah, if you can do that, Ted, that'll be good. Thank you. Juan Carlos, go ahead.
Hi, can you hear me?
Yeah, we can. Go ahead.
Okay, thanks. I guess, well, I understand that the discovering problem and the splitting and the dynamics of the network. What I'm still not sure I understand, and that was probably an answer, but I couldn't hear well from Richard's question before, is whether we want to also consider the onboarding part, or are we just dealing with the network when it's already set up, and we just want to make sure that it works, or are we dealing also with the onboarding of new devices, the authentication, authorization, all that?
Ted Lemon here. I think that's a really interesting problem, but it's also probably specific to the individual type of stub network. And so, we could maybe do something like that, but I don't know that it's necessarily in scope. Certainly for the thread use case, we already have a solution for that. And so we wouldn't need the IETF to solve that problem for us, but there might be a use case where that does matter. But, we already have onboarding for Wi-Fi networks. You type in the password. So.
Go ahead, please. Thanks.
Hi there, Tom Hill, BT. Having read now through the proposed charter, and I think in follow-up to Richard's question previously around security, I think it's incumbent upon us, actually, it seems like feature creep, I think, in some cases, but I think it's incumbent upon us to at least consider basic security as a remit of this charter of SNAC, on the basis that if we don't consider basic security at the borders between stub networks and infrastructure networks, for example, in particular, on a per stub network basis at the very minimum, then it will be down to each individual vendor to come up with what they think that should do. We're in danger here a little bit of noting that we are moving away from double NAT as a method, but also ignoring the fact that we today, as an industry, rely quite heavily on the obfuscation of double NAT and NAT in general. We really should, I think, be more prescriptive. I don't think it has to be super complicated. Simple things such as this stub network does not have by default access, or any stub network does not have by default access to the internet unless you enable that. So I think it's worth being clearer in the charter that simple security options for stub networks are worth considering or at least specifying.
Okay. So if I understand you correctly, right? You don't want default connectivity from the stub network to the internet. Is that like something what you're expressing? Because I'm trying to like
That's
boil
one
it down.
example. I think it's the 2 points here are that leaving it undefined means that it will potentially not be done very well. And it is incumbent upon all of us in 2022 to think very hard about security with everything we do. Hence, we end up with more, Mirai bots, or the next horrible, great big DDoS exploit that comes along. So I think it's very, very important that we start with security baked in, at least at a very basic level.
Okay, thank you. Ted, did you want to skip ahead of Eric?
Yeah, he motioned me forward, so I'm obeying. Yeah, so the question that I would have for you is, do you want the equivalent control over individual devices that connect to the infrastructure network? I mean, I see someone over there nodding. I happen to agree with him. but that's really what you're talking about. And that's where I said, that's actually an interesting problem. That's not a trivial problem. And it's also probably is a different problem depending on the particular type of network. So yeah, of course.
Tom Hill again. Perfect is the enemy of good. And I think if we focus too hard on individual devices, every single light bulb, and trying to worry about the security of each one, we will get too far into the minutiae of security. I think there's definitely there is a huge benefit to thinking of this in broad swathes. So per stub network is going to be far more manageable than per device. But it's certainly better than no security thought at all when we go into this.
So the reason that I'm pushing back on this a little bit is because I think that your model of what a stub network is incorrect. A stub network is essentially equivalent to a bridge. And that doesn't mean that we don't want to solve this problem. But the reason that I say I agree with you on this is because when we went at Apple to implement this, our first cut at this was to say, we're not doing that. So basically, and by the way, we don't support DHCP-v6 GUAs. And so your devices on the stub network cannot communicate with the internet at all, period. However, that turns out not to be generalizable. That's interesting for the case of Apple, because Apple's devices are all that way, right? But when we start talking about Matter or some of these other ecosystems, they're expecting to be able to connect to the cloud. And so that model didn't work. And so what we came up with as a model is that the CE router is probably the place where this should be done, not the stub router. Because the stub router is basically a dumb device, right? It's not managed.
I'm
okay.
Sorry, yeah. I am suggesting that I am certainly suggesting that your CE router is the arbiter of, the ultimate arbiter of security on your network. I think if it has visibility of a stub network that it sees as a holistic, the other side of a stub router, it should be able to set at least some form of security policy, general policy for that holistic group of devices.
Thank you. Eric, go ahead.
Okay, Eric Veng, the AD for this buff. I'm just concerned by the time. The paragraph there are describing kind of the purpose, but we don't see what the work items are, and we need to discuss this as well, right?
Yeah, thanks. Go ahead. Thank you, Eric. Eric, yeah, go ahead.
Yeah, Eric Klein. I wanted to ask if it's in scope to talk about network partition discovery and mitigation and that kind of stuff, and if it is, what text in here would support?
I think it's certainly worth talking about. I think it's probably, we're not going to be able to do it today, but it's certainly something we can continue discussing on the list if we decide to go forward with the working group.
Thanks.
Thank you. Thanks. Okay, so now looking at the deliverables, so there's 4 proposed deliverables. So looking at the first one, I don't know if you can see the highlight. So it's a document describing basic set of functionality of a stub network router that enables mutual discoverability and mutual reachability between stub network hosts and infrastructure hosts. So does anybody have questions about what this means? Okay. So instead of me reading through, I'll just like switch to a different set of slides to ask if people understood all these things, because you had some time to read this charter in the beginning. Michael?
I didn't hear any clear result from that security discussion as to whether there was a charter statement about security that was being asked for or was missing, or so I don't know if that conversation didn't seem to end with a charter amendment.
I think that is correct, right?
Yeah.
Like, and that's something certainly open for discussion, right? Because we're not going to solve that here today, right? Like we have like 10 minutes left to go, right? We're not going to be able to solve whether that's going to go in the charter or not, right? But
Tom Hill from BT again. My hope was that the charter could be security aspirations could be clarified in the charter. I think they're skimmed over at the moment.
okay, sounds good. Thank you. Ted, can you take a note to add a discussion regarding that onto the mailing list? Thank you. Stuart, go ahead.
I would support having the charter say that the working group, if formed, will consider security questions. I don't know whether we need to say that about an IETF working group, but if it's easier to clarify that we will consider security questions.
Sounds good. Thank you. Okay, so so there's like I think like 2 issues that kind of have we have to resolve. So one of them is the security related questions, and the other one that came up is Eric's point about network partitioning and healing and so on. So I think Ted, if you can kind of make a note, like I know you're taking notes at the end of the charter on the Google Doc, but if you can kind of like try to close the loop on that after the meeting. Security was one of them, and Eric Klein's question about network partitioning and healing, whether that's in scope or not. So if you can. Sounds good. So other than that, is there any questions about the clarity of what's written? So like, 2 things came up that's not like there in the text right now, but do you have any questions about the clarity of what's actually in there? Gabe, go ahead.
Assumption. Yes, I have a question about clarity. I'm not sure what the difference is between the second and third deliverable. I see that the third one is more general and includes the second one. So I'm not sure why the second one exists, unless the point is to, the second one might be a simpler one to address initially, and maybe the third one would be dropped if it's more general. So yeah, please clarify what's the relationship between the second and third. Thanks.
So I'll clarify that in the document, but just to answer your question briefly, the difference is connecting to the internet is sort of like cloud connectivity. Connecting to adjacent links could mean connecting within like a corporate network or something like that. And the problems are slightly different because one of them involves using a default route and one of them possibly involves more complicated routing. That's basically the distinction.
Includes internet already.
Ted Lemon again, the global internet.
Was that clear, Gabe? Okay, thank you. So We did talk about scope, so there is 2 issues that came up with the scope. So we'll try to address it on the mailing list after this. And does anybody think this is like too ambitious to solve? If you have any concerns, hum or come to the mic, anything? Okay. Is there anybody who feels this is not a problem worth solving? You can hum. Okay, don't hear anything, nothing remotely either. If you have something, please chat. Thank you. Okay, so now, Eddie, if you want to come up here, like so we can see the response. So now we are going through with like a set of questions, which is like typical for any working group forming BOF. So the first question is, who are here, or if you're online, please like raise your hand for this. Otherwise, like who's willing to author documents, contribute to documents, and edit documents in this problem space? Please raise your hand. So the count of the room is about like 15 people. Doesn't matter what the number is. And remotely, we have 1 person who's like interested in doing that. So I would say there's like fair interest in doing that. Who's willing to review documents? You can hum. Few people on the online as well. Is there support to form a working group with the proposed charter, assuming that the clarification questions that Gabriel asked and 2 scope questions that Eric and the gentleman from BT, I didn't get your name fully, brought up, if they are resolved, are you opposed to forming a working group? So are you willing to support a working group with the charter? So that's the question, pending the edits to the charter. So that this is not like binding until the edits are done on the mailing list and agreed upon, okay? So the question is there support to form a working group with this proposed charter with the pending changes? If the answer is yes, please hum. If you're remote, please raise your hand. Thank you. Is there anybody in the room who feels that a working group should not be formed in the space? Hum if you do. If you do not believe that a working group needs to be formed. Don't hear anything. Remote, if you have any concerns with the working group being formed, please join the mic line. Not seeing anything. So there is, I would say, indication of support to form a working group, and we'll take up the further discussion on the list for the proposed charter and summarize the discussion towards our AD, and AD can have the last word.
The last, the last word, it looks like funny way to say it. Anyway, I would love really to get this future working group, if approved and continued, to not boil the ocean, right? We are all coming from HomeNet, which was kind of too long. So let's keep it simple, KISS, right?
Thank you. Thank you very much. Amen to that, as people say. Thank you. So any last comments from anybody who's remote? Thank you. So the summary is like there seems to be indication to form a working group with this charter in this problem space, and the charter needs to be finalized on the mailing list with some further discussion required at least on 2, I would say, kind of major topics, and to kind of tighten down the scope. So that's a summary. So thank you very much. Thanks all for coming, and have a great lunch. Thanks. Thanks.
So I'm on the campus with 20 of they have basically decided this stuff. And I think that's a sales because right now I would like to market as just give me
travel to the UK?
I did. We've met in Vienna. I have one of your cards.
so there is a BT group that's talking to many security guys.
Oh.
Key point is that a lot of this is about putting the security costs of being inside the all so that's why I think that some of the questions are